Very good morning to all. And in this recorded video, we will discuss about, we will continue our discussion. In the previous discussions, we were talking about the interior lighting design. And in that, we were discussing the maintenance factor and the overall maintenance factor and the factors affecting the maintenance factor. And based on that, we have four maintenance factors, namely room surface maintenance factor, lamp lumen maintenance factor, etc. Like four maintenance factors we have. And when all the factors affecting the maintenance factor are coming into the picture, then we will call it as overall maintenance factor. And the overall maintenance factor is calculated by simply multiplying all the different maintenance factors, and you will get the resultant maintenance factor. And why this overall maintenance or resultant maintenance factor is important is that we will use that maintenance factor, overall maintenance factor, in this equation of illumination, finding out the illumination on a working plane. And this is a method of light calculation on a working plane. And this method is most suitable for interior lighting design, where a high proportion of light on the working plane is reflected by internal surfaces. And this method actually used for ultimately for the calculation of the net illumination on a particular working plane. And also it will, if you have the required illumination level on a working plane, then you can find out, using this method, you can find out the number of luminaires required to provide a specified to provide that specified or the required illumination on the work plane. Actually, this illuminance in this sentence, actually in this explanation, is actually not the brightness. Don't misunderstand with the brightness terminology. Why? Because the brightness is also otherwise called as illuminance, but here it is illumination itself, and the unit is lux, lumen per meter square. And the following formula given by the E is equal to N into mf into uf into phi divided by A. This formula can be used to find out the number of luminaires, or the number of lamps required to produce a required illumination level on a working plane. And the required illumination level is E in lux. And the maintenance factor, utilization factor, actually we have defined that. In general, we have understood what you mean by utilization factor, but in interior lighting design, the utilization factor will play an important role, so that we will also discuss that factor also. And phi is the lumen output, the initial lumen output of the luminaire. That means initial lumen output means the luminaire is working at least that means the lumen output given by the luminaire after 100 hour of operation. Okay, that is what I mean by initial lumen output. So this is phi, and A is the area in meter square of the working plane. The mf is maintenance factor, uf utilization factor, and capital N is the number of luminaires required, and E is the illumination in lux. Now moving on to the utilization factor, you have to understand this and the definition. In general, you can define utilization factor. It is the ratio of the lumen received on a working plane divided to the lumen output of luminaire. And yes, and if the lumen output of luminaire is specified or is given or is known, then you can find out the lumen received on the working plane. And the utilization factor takes account of the loss of light due to absorption on room surfaces. And it depends on three factors. First one is type of luminaire. A luminaire with a luminaire definition, you have to remember how to keep it in mind. And a luminaire with a concentrated light output directed on the working plane will have a higher utilization factor than a luminaire with a dispersed light output. And that can be understood with this figure. Okay, figure A we have, and figure B we have. And in figure A, actually it is more dispersed light is emitted by this light source. The lumen output of this luminaire is more dispersed in almost all directions. But in figure B, the luminaire actually is the lumen or the light emitted by this luminaire is more of concentrated type. So in that case, we will get two different utilization factors, and in the first case we will have a low utilization factor, and when you use a concentrated light concentrated luminaire like shown in figure B, then you will get a high utilization factor. Okay, the first factor is the type of luminaire, and the type of luminaire, how it affects the utilization factor, that is described by this figure A and figure B. Now, second factor affecting the utilization factor is room index. Room index. Actually, room index means room index is a mathematical scale, you can say, or mathematical model that will tell you the length and width of a room, and also the mounting height. And the room index is modeled as room index is given by L into W divided by L plus W into HM, where L and W are length and width of the room respectively. HM is the mounting height. And this takes account of the length L and width W of the room and the height of the luminaire above the working plane. So by varying this L for different values of the length of the room, width of the room, and also the mounting height, the room index will vary. And the room index, actually why this room index is defining is that the manufacturer of a light source or a luminaire, for example, or the manufacturer or the architecture should know the values of this room index. That means actually, and also the manufacturer of a lamp of a luminaire. For example, if you consider a LED luminaire, LED, that means LED light, but lamps are located in a group of LED lights are used, then you can say it as a luminaire. And the manufacturer of that luminaire, they will provide or they will specify a room index value for which their luminaire will have the maximum performance. Maximum performance means it will have the uniformity ratio, high uniformity ratio for a particular or a specified room index. That means a room with so and so length and so width and can be illuminated more effectively using this luminaire. That is what our the manufacturer will tell you. Okay, and they will specify the length of room and width of room in their manufacturer the data sheet. Manufacturer's data sheet. Okay, they will specify that, and also they will tell you that this luminaire is having the maximum performance or will give you the uniform illumination or the high uniformity ratio if you mount this luminaire at a particular height. or in in a particular range of mounting height. Okay, so and also yes, that you uh, can be explained using these two figures. Again, figure A is our case 1 and figure B is our case 2. And in figure A, in the case 1, okay, case 1 we have high room index and high utilization factor. High utilization factor. High room index means the mounting height is low, okay, and length and width, this multiplication factor is high. So we have here the width of the room is very high comparing to the length of the room. Okay, and also the mounting height is comparatively low when you compare with this figure B. So in that case, you can say that this figure A, that is case A, is having more value of room index, and the more value of room index means high utilization factor. That means more value of room index means you can use more number of luminaires, so that the utilization factor will increase accordingly. And in this case we have the room index is low. That means the length of the room and width of the room, if you compare, width of the room is very much less than the length of the room, and also the mounting height is very high comparing to the first case. So in that case the room index will be small as given by this equation, and you can use only a few luminaires at a maximum mounting height with increased value of mounting height. So in that case the reflection from the walls and also the loss of lumen due to reflection also increases, so the utilization factor will be decreased. Yes, so that is what the room index, which is the second factor that will affect the utilization factor. Then the third factor which affects directly the utilization factor, or the loss of lumen from the luminaire, is that the reflectances of room surfaces. That means the uh, actually the room surface will be painted by different colors, maybe high contrasting colors and with low contrasting colors. So that means high contrasting colors means that on incident while yes, high contrasting means the reflection of incident light radiations will be maximum, and low contrast means the reflection by the low contrast colors will be small, and most of the incident light will be absorbed by the color, by the particular low contrast color. So in that case, that also affect the utilization factor. That means the lumen actually reaching on the working plane. So yes, bright colors with high reflectances. Okay, bright colors with high reflectances, that means high maximum amount of incident light is being reflected. That is what you mean by reflectances. So bright colors with higher reflectances resulting a higher utilization factor, and a high utilization factor will mean fewer lamps are needed, resulting in a more efficient energy usage and a lower capital cost. That means as the reflectances value increases, then maximum amount of incident light will be maximum amount of reflectance light will be reflected. Incident light will be reflected by the room surface. So that means uh, Yes, we have two cases again, case 1 and case 2. And in case 1, uh, in my room, suppose imagine a room, then in the room surface are coated with this highly contrasting or bright surface color, that is yellow color. I'm painting my room surface. So in that case, the reflectance value of this bright surface is very high. So that means the about 90 percentage of the incident light radiation on the surface will be reflected back to the working plane. Then, so the net lumen reaching on the working plane will be improved. So you can say that high utilization factor is obtained. And in case 2, if the room surface is of dark surface, okay, as shown in figure B. So this is figure B as shown in case 2. Then the reflectance value of this kind of surface is low, so that it will absorb the light radiations, a large amount of light radiation by this room surface itself. So a large amount of lumen output which is emitted by the luminaire will be absorbed by this dark surface, and the net lumen output reaching on the work plane will be reduced. So you will get a low utilization factor. Okay, so these are the two cases. Then so these are the three important factors that affects the utilization factor directly. Okay, and the utilization factor while designing an interior lighting system is calculated by considering all these factors together. Okay, as in the case of maintenance factor. So the calculation of utilization factor, like our calculation of overall maintenance factor, is given by, first of all, this is the calculation of utilization factor is a procedure. Okay, and this procedure consists of 4 steps, and we have first of all, the first step is to obtain reflectance factors for room surfaces from the architect or interior designer. That means you know that the reflectance factors for high contrast color and also low contrast color is different. So it will vary from room surface color to color. So in that case, you have to approach to an architect or an interior designer in order to get the reflectance factor value. So typical reflectance factor value is given in table 1.7. That is color white or cream, we have 0.7, 0.8, 0.7 or 0.8, yellow 0.6, light green or pink 0.5, lesser, then sky blue or gray 0.4, even lesser, then brown we have even the small reflectance factor value. So it is best, so it is self-explanatory that why we will why the whitewash of room surfaces is have more advantage than the uh, other color painting. Okay, though, so then the next step in calculation of utilization factor is to acquire manufacturer's data for luminaire selected. That means, yes, luminaire selected, that will actually this table 2 gives that. Then calculate the room index, then evaluate utilization factor from manufacturer's data. That is again table 2. Table 1.8 is table 2. So these are the 4 steps. Then these 4 steps can be explained by taking an example. That is, the example problem is calculate the utilization factor. So utilization factor you have to calculate for a room with the following dimensions. So a room is having the following dimensions. It is given in the problem itself. So the length of the room is 8 meter, width of the room is 6 meter, then height of the room is 3 meter. So with this data of that particular room, actually we cannot do anything. But on adding to this data, we have another important data, that is height of working plane is 0.8 meter. Height of working plane is 0.8 meter. That means we have a room like this. And whose length is given and width is also given. Okay, width. So this is length and width. Length is 8 meter, width is 6 meter. Then height of this room is given as 3 meter. And the working plane is, height of working plane is 0.8 meter. That means I have a, yes, suppose this is my floor level. Then this working plane is actually situated 0.8 meter from the floor. That is what I mean by the height of working plane, 0.8 meter. So the mounting height, you can calculate from all these given data as, yes, height we have 3 meter, the overall height, and 3 minus 0.8, that will be the mounting height or the effective height at which the luminaire has to be placed. So 3 minus 0.2, so mounting height will be equal to 2.2 meter. So we have length, width and mounting height, so that we can use this formula room index, that's equal to, so we can find out the room index equal to length into width divided by L plus W into mounting height. So that will be equal to 8 into 6 divided by 8 plus 6 into mounting height, that is 2.2. So that will be equal to 1.558. Actually this has no unit, so this is a value only, a factor 1.558 I got, and I am taking it as approximately 1.5. So I got the room index value. So the first step is, yes, obtain reflectance factors for room surfaces from the architect or interior designer from table 1.1.7. Yes, and the room, yes, here in the problem, in the problem it is specified as the room reflectances are ceiling 0.5, walls 0.3 and floor 0.2. Ceiling 0.5, walls 0.3 and floor 0.2. So that step is over. The first step is over. It is already given in the problem itself. Then next is calculate room index. So we have calculated the room index as 1.5. We got it. Then yes, from these two steps you will get the ceiling. Yes, from these the first two steps you will get ceiling 0.5, walls 0.3 and floor 0.2, which are the room reflectances values, but we need not to calculate it from manufacturer's data or table. because it is already given in the problem. See, in the ceiling it is 0.5, walls 0.3 and floor 0.2. That means that much. 0.5 means 50%, 0.3 30%, 0.2 20%. So that much reflectance is contributed by the ceiling, wall and floor respectively. Okay, then after calculating the room index also, then you have to observe this table 2, which is typical manufacturer's data for a typical twin tube fluorescent luminaire is used to calculate the utilization factor. And actually this manufacturer's data is for a twin tube fluorescent luminaire. Okay, so that as the luminaire selected changes, this manufacturer's data will change and all the values will correspondingly change. So we have the values, the reflectance values, room reflectance value for ceiling, wall, then this is for floor. For this, actually this table, this manufacturer's data is applicable for a twin tube fluorescent luminaire, and assume that we are using this twin tube fluorescent luminaire, so that we can use this manufacturer's data for the calculation of utilization factor. So in the problem it is given as in the ceiling it is I think it is 0.5, and in the wall reflectance is 0.3 I think. Okay, then from the floor it is 0.2 reflectance. Okay, so this is 0.5, 0.5, then this is 0.2, 0.2. So 0.5, 0.3, 0.2. So this row you have to select first of all. Okay, so the utilization factor can be the any value in this particular selected row. Next, we have 1, 2, 3, 4, 5, 6, 7 and 8 values for utilization factor, right? But we should have a one unique utilization factor for the given room. So for that we will use the room index, which we have calculated in our problem as 1.5. So this is these values will give you the room index. Okay, so that our 1.5 you have to select 1.5, so you have to select this column and this row, and particularly you will get a particular value intersecting this row, selected row and column. You will get a 0.63 value. So 0.63 will be the utilization factor. Okay, utilization factor of the given problem. So our utilization factor will be 0.63. Okay, yes. So then utilize this after finding out the utilization factor value. Then what we will do in interior design is, yes, we will substitute the calculated utilization factor here. Okay, suppose we have this E known value of illumination index, then maintenance factor is also known. Okay, and the initial lumen output of that particular luminaire is also given in the manufacture in the problem. That is phi is given. Then A can be calculated with length into width, that is 8 into 6, that is 48 meters square. That is, so A is also known. Then you can calculate by rearranging this formula. You can calculate N. So what is N? N will be the number of luminaires required, or is number of luminaires required for in order to get the particular illumination level on that work plane. So that is our design procedure. Okay, now one by one we are the design for designing an interior, like a good interior lighting system, we have discussed the maintenance factor, the utilization factor we have discussed, and another important design factor which is to be considered while designing an interior lighting system is space to height ratio. So space to height ratio we have already discussed in module 1. So I'm just giving you the slide. You can refer this. Okay, and this and the yes, and the uh, importance or the significance of defining or specifying the space to height ratio is to get an adequate level of uniformity ratio value. That means the luminaire, if you purchase from a market, that luminaire will have a manufacturer's data or a data sheet, and in that data sheet they will specify everything, that is room index, the desirable room index, the desirable mounting height, and the desirable maintenance factor value, and the desirable reflectance value. All that will be given in the manufacturer's data. And another important significant important factor, design factor, is space to height ratio. So the desirable value of the space to height ratio will also be given by the manufacturer for that particular luminaire, so that the luminaire will perform or will give the uniform illumination over the working plane. Okay, so yes, space to height ratio is the ratio of space, yes, space as shown in this figure. So luminaire, this is luminaire 1, LU1, LU2, luminaire 2. Okay, and space, horizontal space is given is as shown in the figure 124. Then yes, it is the ratio of space between luminaires S to their height above the working plane, that is mounting height, is known as the space to height ratio. So mounting height is also labeled in this figure. Then manufacturers will specify a recommended space to height ratio for each of their luminaires in order to get the maximum efficiency of their product. The manufacturers will specify the recommended space to height ratio for each of their luminaires. Then ensuring that, so this specifying a recommended space to height ratio is to ensure that luminaires are spaced within the recommended value will mean an acceptable variation in illuminance or illumination across the working plane. That is, the working plane will be illuminated so that an acceptable variation in the illumination on the working plane is obtained. Okay, and the variation in illumination, okay, the variation in illumination is expressed in terms of uniformity ratio. So what is uniformity ratio? We have already that we have discussed, we have defined it. So uniformity ratio, if you consider a working plane like this, okay, the working plane, if you consider like this, then this working plane will have infinite number of points if you consider on this working plane. And if you consider, if you calculate the illumination on all these points, then the illumination will vary from point to point. Okay, that means some points, if you take, at some points the illumination level will be very low, that means minimum, and at some points of working plane the illumination level will be maximum. So what we will do is we will take an average of all these values of illumination at different points and let it be E average, that means average illuminance, average illumination. Okay, illuminance is nothing but illumination, and divided by, yes, yes, so the minimum to average, so this average will come to denominator. So yes, so uniformity ratio UR will be equal to Yes, we will take the average of all the values of illumination measured in lux, and we will keep it in the denominator E average, and we will take the minimum value of illumination on the working plane. So that let it be E minimum, E min. So, and we will take the ratio of these two values, that is defined as the uniformity ratio. So uniformity ratio is defined as the ratio of minimum to average illumination normally taken on the working plane. So working plane uh, is our consideration. That means the various points on the working plane is our uh, point of consideration. Okay, and it is so that is defined as the uniformity ratio. So uniformity ratio, if you make this minimum illumination level on the working plane uh, to the average value, then you will get uniformity ratio as 1 equal to 1. Okay, that means the the expected value, I mean the illumination on the working plane under consideration is uniform or is constant or is almost constant over the entire working plane. That means if you consider any point on the working plane, you will get a constant value of illumination in lux, measured in lux. Okay, that is what we mean by uniformity ratio equal to 1. And that value is average illumination, E average. Okay, so space to height ratio, another design factor. So how you will take this design factor into account while designing a interior lighting system is can be explained by considering this example. That is, a factory area, consider a factory area is 40-meter long, 20-meter wide, and is 8-meter high. Point source luminaires are suspended 1.5 meter below ceiling level as shown in figure 125. The working plane is 1 meter high, that is also shown in the figure 125. Okay, and 1 meter high from the floor level. Calculate the minimum number of luminaires, and you should remember that this all these luminaires are considered as point source. Okay, point source. Then calculate the minimum number of luminaires which must be installed to conform with a recommended space to height ratio of 1.5 is to 1. Space to height ratio is given as 1.5 is to 1. That means 1.5. So that means S space to height ratio, S by H is 1.5. You have, okay, and so the S will be equal to space to height ratio means mounting height, you have to take it. So space S, that means the space between two adjacent luminaires is S is given by 1.5 into HM, that is mounting height. But the mounting height is actually this height. That means the luminaire, the height between the luminaire and the working plane. Okay, so that is HM, mounting height. That means HM will be equal to the total height 8 meter minus 1.5, which is the height which the luminaire is situated 1.5, and plus 1 meter, which is the working plane height of the working plane. So then only you will get the mounting height. So that means 2.8 minus 2.5, that means 5.5 meter. So the space, uh, the distance between adjacent lamps, S, space between the luminaires, here the luminaires are considered as point sources. So S will be equal to 1.5 into 5.5. So that will be equal to 8.25 meter. And this 8.25 meter. Okay. So yes. Now what the examiner is asking you to find out is that Calculate the minimum number of luminaires which must be installed to conform with the recommended space to height ratio of 1.5 is to 1. Now, let us consider the top view of that particular factory area. Particular factory area. If you consider the top view, then each luminaire can be considered as a point source, that is like this. Okay, just like this, that is plus sign, like this. So it is situated like this. Now the adjacent distance between the luminaires is we have calculated s equal to 8.25 meter, right? 8.25 meter, yes. So you have to make sure this adjacent spacing, okay, 8.25. So then you have the width of the factory area is 20 meter and length of the factory area is 40 meter. So width divided by this s, width divided by 8.25 will ensure or will give you the number of luminaires required, or that is to be fitted along the width of the factory area, right? So that will be equal to, width is 20 and divided by 8.25, so that will be equal to 20 divided by 8.25, 2.42, 2.42. But this is number of luminaires, so this must be a number, so I am rounding it as, I am taking it as 3, okay, approximately equal to 3. So that means 3 number of luminaires along the width of the factory area. Then along the length of the factory area, how much luminaires you have to place. So that is given by the equation, length divided by again the adjacent spacing, that is L by S. So that means 40 divided by 8.25, that's equal to 40 divided by 8.25, 4.8, and I'm taking it as 5 number of luminaires. So that means along the width 3, along the length I have 5, 1 2 3 4 5. Okay, so that again the space to height ratio and all other are or all other design specifications are met with these calculations. So I am placing, yes, so my layout diagram of the luminaire will be shown as shown in this figure 126, that is 8 meter, 8 meter, 8 meter. Okay, so yes, 5 lumen, yes, 3 and 5, right? So 3, 20 by 3 means I have a, yes, 6.67 between the 6.67 between the lamps, and 3.3 here, and 3.3 between the wall, sorry, as a clearance from the wall. Okay, clearance of the luminaire from the wall, I'm taking it as 3.3, 3.3. Okay, yes. Then yes, I have along the length of the factory area, I have 5 luminaires. So 40 divided by 5, that's equal to 8 meter. So 8 meter will be the distance between the two luminaires which is placed along the, or which is arranged along the length of the factory area. So 8 meter, 8 meter, 8 meter, 8 meter. So 5, so 4 into 8, 32 meter is covered, and the remaining 8 meter can be divided as 4 meter and 4 meter as clearance from the walls. So this is our example problem. So with this we have understood the maintenance factor calculation, utilization factor calculation, the factors affecting the utilization factor, then space to height ratio, factors affecting the space to height ratio, and how to calculate the space SHR in interior lighting design. So thank you.